Welcome everyone. This is the next class day covering Lewis dot structures. In the last class we did ionic Lewis dot structures. Today we're going to be doing covalent. So we're going to skip straight ahead to the steps for covalent structures. For those of you guys that have been in class, you know that we put the steps in for the ionic structures in the flowchart at the back of your homework packet. If you have been in class and you know where that is, please go ahead and put these covalent steps in that same flowchart on the covalent side. If you have not been in class, go ahead and just take notes for right now, and then I will show you where that goes when you return. So the first thing that we're going to do, remember that we are dealing with covalent now, not ionic. So everything we've been doing up to this point has been with ionic. So we're switching gears at this point and starting with covalent. And with covalent, remember we have to understand that we're no longer dealing with any of our metals. So we're working all on the non-metal side of the periodic table. So you should have 2 or more non-metal substances as a part of your compound. So make sure that you know what non-metals you're working with. That's the first step, and that they are in fact both non-metals. Then we're going to count up all of the valence electrons for each of the substances that we're dealing with, and then add those together to get the total number of valence electrons that we're going to be representing. Now, we have to remember that valence electrons ultimately go in pairs. So then we're going to divide this number by 2, and this number of pairs that we get is going to be what we use to double check our answer and make sure that everybody's needs have been taken care of. In step 4, we're going to identify and write down our central atom. To identify the central atom, there's a couple of different ways that we can look at it. Technically, it is the least electronegative element. So the one that is, of the nonmetals, the one that is either furthest to the left or furthest down. And so we have to look at those in relationship with each other. The other piece of that is if you see carbon in your compound, carbon is almost always the central atom. So if carbon is there, we just know that carbon is going to be our central atom. The other thing that we can look for is atoms that are single atoms. So if we have a compound where one of the elements only has 1, and all of the other elements, or the other element has more than 1, then the one that is single is going to be our central atom. One thing that you need to watch out for here is to remember that hydrogen can never, ever, 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 ever be the central atom. So looking for and identifying that central atom seems like it's going to be really difficult, but when you see our examples, you'll see that it's not as complicated as it sounds. And then what we're going to do in step 5 is we're going to arrange all of our outer atoms, so all of the other atoms around that central atom that we've identified, and we're going to give 1 bond to each. Now what we mean by bond is a line. So a bond equals 2 electrons, and that is going to equal 1 line in between 2 elements. So we can also still represent electrons. So an electron is a dot, and that equals 1 electron. So we still have those tools that we can use with writing individual dots, but this is the piece that changes when we do covalent, is adding these bonds, because that is what represents that electrons are being shared. Remember, we're no longer talking about transferring. These electrons, now that they're covalent bonds, are being shared between those 2 elements. So we use a line to represent that those electrons are being shared. After that, we get everybody separated by 1 bond. We're going to place in step 6 the remaining valence electrons around the central atom, and then we do the same for the outer atoms. So what I want you to notice here is that we always work with the central atom first and then move out from there with bonding and setting it up. And then we come back again to the central atom, worry about its valence electrons, and then move our way out again to the outer atoms. At this point, once you've given everybody their valence electrons and represented all of those, you're going to check to see if everybody's octet, remember our magic number is 8, is satisfied by what you've done. If everybody has 8 valence electrons, then you're good and you're done. If not, you may need to rearrange some things or pull some electrons from the different atoms to create an additional bond. Your clue that you have to move on to step 8 is that everybody's octets are not satisfied, or if you have an odd number of electrons that you're representing. So again, we'll look at that in just a second. So please make sure that you have these steps in your notes, or if you, like I said, if you've been in class, please make sure that they're entered into your flowchart. So let's look at a couple of examples. The first example that we're going to look at is OCl2. With OCl2, we have 2 nonmetals. Oxygen and chlorine are both nonmetals. And so the first thing that we're going to do is count their valence electrons. So chlorine has, let's try that again. Okay, so oxygen, has 6 valence electrons plus 2, because we have 2 chlorines, times its 7 valence electrons. So 2 times 7 is 14, plus 6 is 20. And remember we said we're going to divide that by 2, showing that we are going to be representing 10 pairs of electrons. Our next step is to identify our central atom. For here, we can see that oxygen has only 1 atom, whereas chlorine has 2. So that makes it really easy to decide that oxygen is actually the central atom. One thing that I want to mention before we get going is that in order to see how these should go together, you have to think about spaces open. So we talked yesterday, or last class rather, when we did ionic, that the number of electrons that are being given have to equal the number of spaces open that there are on the receiving atom, or the receiving ion. Here we're just looking at those spaces open. There is no transfer of ownership here, but we need to make sure still that everybody's open spaces are all taken care of, because that's how we get to 8 for everyone. So we're going to put oxygen in the middle. Again, it is the only single atom, and it is, too, the least electronegative. It is further left on the periodic table than chlorine is. And then we're going to add 1 bond on either side for each of the chlorines. Now, what I'm going to do is I'm going to show you where the electrons are. This is not going to be part of your final answer, but it helps you to picture who's contributing what number of electrons to the bonding effort. So at this point, oxygen has contributed an electron to this bond and an electron to this bond. So when we come back to the middle atom, to the central atom, our next step is to give it the rest of its electrons. Remember, 1 line equals 2 electrons, and we know that covalent bonds are sharing those electrons. So 1 of those for each bond is coming from oxygen. Oxygen has 6 though, so we have 4 remaining electrons to represent. Then we come over to chlorine. Chlorine has contributed 1 electron to each bond also, and each chlorine atom has 7 valence electrons, so we have 6 more. So there's 7 valence electrons, 1, 2, 3, 4, 5, 6, and then the 7th one here that it has contributed to sharing. 2, 3, 4, 5, 6. So We worked on the central atom first, gave it the rest of its electrons, and then we worked on the outer atoms. So now we need to check that including the shared electrons, everybody gets to 8. So what I do is I cover up my outer atoms, and I look and see, did I get all of oxygen's electrons? So I have 1, 2, 3, 4, 5, 6. Oxygen has 6, so that's right. Now, including the shared electrons, I have 7, 8. So I have filled oxygen's octet. Now let's look at chlorine. Chlorine has 1, 2, 3, 4, 5, 6, 7. That matches the number of valence electrons it brought. Now, including the shared one, it has 8. Same thing over here. 1, 2, 3, 4, 5, 6, 7. Including the shared one, it has 8. Again, the circles that I just made around those electrons are not part of your answer. That's just me showing you how to count. So my final answer would look like this without all of the circles. So oxygen would be in the middle, chlorine would be on either side. We gave oxygen its 2 extra pairs of electrons, and then chlorine has its additional 3 pairs of electrons. At this point, everybody's octet is filled, and we're good to go. The next example that we're going to do is carbon dioxide, CO2. We have carbon, so we know that's the central atom. Then we're going to, we need to count our valence electrons first. I got ahead of myself there. Carbon has 4 valence electrons plus 2 times 6, because there's 2 oxygens. So 2 times 6 is 12 plus 4. 2 times 6 is 12 plus 4 is 16 electrons divided by 2. Tells me that I'm going to have 8 pairs. Carbon goes in the middle. I've got 1 bond to each oxygen. And then I come back and I know that carbon has contributed 1 electron to each of these bonds. But it has 4, so I have another pair that needs to be represented. So that all looks good so far. Now, I have oxygen that has contributed 1 electron to the bond also, but it has 6, so that means I have 5 more electrons to represent. Okay, so we stop here and we look at this, and there's something immediately that sticks out to me that is not right. We cannot ever have single electrons. So the fact that I have a single electron right here and a single electron right here before I even count tells me that something's not right. So I'm going to go ahead and count. I've got 1, 2, 3, 4 for carbon. That matches its valence electrons. But if I look at the shared, that's only 5 and 6. So I have not met its octet. So I know doubly at this point that it's not right. So what we're going to do is we're going to pull this electron from this side, and then this electron from up here, and we're going to make a second bond. And we're going to pull this electron from this side and this electron from up here and make a second bond. When I do that, that erases those 2 electrons at the top, and it erases the 2 electrons that were standing out on either side. Now I can count, and carbon has still contributed 1 electron to each bond, and oxygen has still contributed 1 electron to each bond. And when I count, it works. 1, 2, 3, 4. There's carbon's 4. 5, 6, 7, 8. I've now made it 8. Then I go 1, 2, 3, 4, 5, 6. There's oxygen 6 shared, 7, 8. So I'm done. There are your examples for covalent, and please take a break and then work on your homework.